आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Salam Namaste Community Radio, Noida.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
आज की प्रमुख स्टेम पॉपुलराइजेशन जानकारियाँ।
विज्ञान के दुनिया से आज की जानकारियां।
चूहे इंसान की सोच से कहीं अधिक मानवीय होते हैं। जानिए वो हमसे क्या चाहते हैं। आज लगभग सभी जंगली भूरे चूहे सिंथ्रोपिक हैं, जिसका अर्थ है कि वे मनुष्य के साथ घनिष्ठ संबंध में रहते हैं, हमारा बचा हुआ भोजन खाते हैं और आश्रय के लिए मानव संरचनाओं का उपयोग करते हैं। ऐसे में वो क्या सोचते हैं? कुछ इकोलॉजिस्ट ये जानना भी जरूरी मानते हैं। चूहों में कुछ हद तक यह दुर्भाग्यपूर्ण प्रवृत्ति होती है कि वहां वह रहना पसंद करते हैं जहां इंसान रहते हैं। एक जीव विज्ञानी ने यह बात कहकर दक्षिणी स्वीडिश शहर माल्मो में खड़ी कारों में बिजली के तारों को चूहों द्वारा कुतरने के बारे में एक टेलीविजन समाचार फीचर में कृंतकों के प्रति लोगों की नफरत को समझाने की कोशिश की। भूरा चूहा रेड्स नॉर्वेजिकस आधुनिक समाज में रहने वाले चूहों की सर्वोत्तम रूप से अनुकूलित प्रजातियों में से एक है। ये चूहे दुनिया भर में मानवों का अनुसरण करते हुए सबसे प्रचुर स्तनधारियों में से एक बन गए। क्या आप धीरे धीरे बूढ़ा होना चाहते हैं? वैज्ञानिकों ने खोजा 2.5 इयर्स तक उम्र कम करने का तरीका। उम्र को कम करना हर कोई चाहता है। इसके लिए लोग तरह तरह के तरीके भी अपनाते हैं। कोई कसरत करता है और प्राकृतिक चीजें खाता है, तो कोई डॉक्टर से इलाज कराता है। लेकिन वैज्ञानिकों ने अब एक नया तरीका खोजा है जिससे किसी भी बायोलॉजिकल उम्र को 2.5 साल तक कम किया जा सकता है। बढ़ती उम्र को कम करने के लिए लोग कौन कौन से उपाय नहीं करते। कोई जिम जाकर कसरत करता है, तो कोई प्राकृतिक चिकित्सा का सहारा लेता है। लोग प्लास्टिक सर्जरी से लेकर पौष्टिक चीजों के सेवन तक का तरीका आजमाते हैं। बढ़ती उम्र को हर कोई रोकना चाहता है, लेकिन यह एक ऐसा सत्य है जिसका सभी को एक न एक दिन सामना करना ही पड़ेगा। वैज्ञानिकों ने एक ऐसा तरीका खोजा है जिससे बढ़ती उम्र को धीमा किया जा सकता है। इससे किसी भी व्यक्ति की जैविक आयु 2.5 साल तक कम हो सकती है। शोधकर्ताओं के अनुसार हरे भरे स्थान शारीरिक गतिविधियों को बढ़ावा देते हैं, सामाजिक संपर्क बढ़ाते हैं और यहाँ तक कि अपराध की घटनाओं को भी कम करते हैं।
STEM एम्पलीफायर।
आज की हमारी विशेष अतिथि है डॉक्टर इंद्रनील सरकार। ये वर्तमान में भारतीय नैनो विज्ञान एवं प्रौद्योगिकी संस्थान मोहाली में सीनियर रिसर्च साइंटिस्ट डीन एवं एडमिनिस्ट्रेशन के पद पर कार्यरत है। उनका वर्तमान अनुसंधान क्षेत्र है इलेक्ट्रॉनिक्स, खास तौर पर स्पिनट्रॉनिक्स।
So myself Indraneel Sarkaar, I am a senior research scientist at Institute of Nanoscience and Technology Mohali. So my background is primarily in the field of spintronics. This is a very interesting field of electronics you can think of, where you use mu degrees of freedom of an electron for application in devices. So instead of using a charge, which is normally used in any device, when you switch on a device or you switch off a device, actually you are saying you are switching off the flow of a charge, or you're letting the charge flow. That's on off. But here what we do is we use another degree of freedom of charge of electron, which is spin, for manipulation of electronic devices. And this is what I specialize in. So spintronics is the field where we use spin, where we try to understand how the spin behaves in materials, how we can fabricate new materials where we can manipulate the spin for applications in both in terms of fundamental science and also for application in chips and other places. And for that matter, if you think, this spintronics is already in play, because your computers, your mobile, you have got magnetic memories, right? They are all based on spintronics. So that's what our field of interest is, and that's what we are working on. So spintronics is kind of an acronym for spin electronics. So what is meant by spin electronics? Normally, if you think of any device, essentially what you are doing, you are making current flow from one end to another. So that is flow of charge. When we say current, it means there is a charge, electric charge, that is flowing from point A to point B. Now when you switch it off, when you switch off a device, actually you are switching off the flow of this current. So the electric current is not flowing. This is the conventional way. Now the problem is, when you have an electric current flow, this electric current is essentially flow of electrons, and this flow of electron is impeded when it collides with something, right? An electron can collide with another electron, many electrons around. So that creates a lot of resistance. That means there is heating of device, right? Energy loss. Also there are speed problem also, how fast you can manipulate a charge and stuffs like that. But when you think of spintronics, which is again application of spin in electronic devices, what you are doing is that an electron has, apart from charge, it also has something called spin. You can think of it in classical terms. Of course in quantum mechanics it means something else, or it's more detail. What it means that apart from charge, it has got a fundamental quantum number, we call it, which can be classically thought of as if the electron is rotating around, and the axis of rotation is kind of spin direction. This is a very classical explanation. Now the beauty of this spin is that you can manipulate it without really needing it to flow through a thing. For example, this spin there are, say, an array of electrons, think of it. So each of them have their own spin direction. Now these spins can interact from a distance. They don't need to flow. So for example, a spin which is standing up, it can see another spin of another electron, which may be is bit little tilted. Now this talks to this spin at a certain distance without going through. So electron does not really need to move. So you have done away with the requirement of electron resistance, flow resistance. So from a distance it is talking to another spin. Now this another spin will talk to another spin without moving. At the end of it, what is happening, that the spin which was at one end, say standing, it can pass its information to another spin which is far off without really moving the electron. So you have done away with the problem of collisions, which is a huge problem in any device, which leads to a lot of heating up, which requires you to put a lot of current or a lot of energy, right? So you have energy efficient devices, don't have heating problem, low power devices. Also these are very fast, because you think of it, you can talk from a distance. You don't really need to move. I'm talking in a very layman's language, but in principle, these are the advantage of spin-based electronics, and this is what is spintronics. So I have been primarily involved in growth of quantum materials, thin films of it, which are used in application of spintronic based things. This has been my past, and this is what I have been engaged through all my career till now. And in future also we are going to work on the same field, because there is a huge scope. When we talk about quantum materials, this is the realm where you fabricate materials in a way, in a certain thickness, in a certain composition, that you expect things which are not seen in a classical world. Like an example, I talked about spins, how spins talk. So we are, my expertise is in development of such kind of thin films or heterostructures of quantum materials. And as I told you that even now we have a huge push, and now we are in the era of quantum materials. So if you think every decade has some buzzword, so quantum material is the word now. So it means that you can, people are very much excited in developing new kind of one single monolayer material, or putting another monolayer top of it. So heterostructures that we call it, one material on top of another, thin films of it. And this is what we are going to work on. Especially we are going to work on a special direction in future, which is something called topological materials. So what topological material means is that in such material, the quantum world is at work in a way that you will have fault tolerances. What it means? That if you can make, say, a thin film of a topological material of a certain kind, again I'm a bit loose here for layman, then if you drive a current through it, and if there is an impurity somewhere, so normally you will expect there is a resistance, because it will hit the impurity like a wall or something. But in a topological material, it will evade the impurity, go around it, and the current will stay. So there will be fault tolerance, and this is a huge thing from an application point of view. But one needs to understand the science behind it. We are more keen in understanding the science of topological material. And I have personally myself got a very good extramural grant from Department of Science and Technology to develop new novel topological quantum materials using something called molecular beam epitaxy. It's a very high-end method of growing thin films, which is also interestingly used in semiconductor technology. So talking about topological materials. So when we say topological material, the word itself says topology, means something with how the topology of the material is. Now here, topology is in the quantum realm. It's not in the classical meaning. It does not mean how the surface classically, topology of the surface. You see, when you have a material, actually it has a collection of simplicity. Essentially, it of course has got also a nucleus, but essentially you have collection of electrons. Now how they talk to each other leads to the behavior of the material, whether it will be conducting, non-conducting, or whatever. Now these electrons express themselves in something called quantum space, which is known as an Hilbert space. Okay. Like we have a 3 dimension, x, y, z. In quantum world, this is a infinite dimensional space actually. Okay. And all these electrons, when they collectively come together, they express themselves in this quantum Hilbert space. This is what is called a Hilbert space. Like just you have a 3-dimensional space, it has got you can think of not 3 axes but many axes. Now this expression of these electrons, how they express their interaction in this Hilbert space forms a topology. Just as if you think of a 3-dimensional material, it has got a topology. Its surface looks maybe corrugated, rough, something. But it's in 3 x, y, z, right? It's down, up, something like that. Now similarly, when there are say lakhs of electrons coming together in a material, they are expressing their topology in something called Hilbert space. Now if you see that topology, this can be manipulated in a material in a way that what we call it gets something called topological protection. Now what this protection means, that even if you twist this topology somehow, it will still keep certain parameters intact. For example, even if you make something topological insulator, if it is a topological insulator, it is such that however you try, you cannot make it metallic. So its property of being insulating is preserved. In that sense, there are various class of topological materials that you can grow. You can make a topological superconductor, you can make a topological magnet. What it means that if you make of certain kind topological superconductor, topological magnet, things like that, these properties will stay topologically protected in spite of how you create a distortion. Well, we are in a very early period, especially in terms of topology. This is what the new world would be, very futuristic. So in the topological context or topological material context, we are not yet there. But we must remember that there is a huge development side by side that will parallelly happen in terms of semiconductor technology because of the methods that we employ. There is a lot of manpower who will get trained. I mean, like PhD scholars who will know how to grow this kind of high quality films and things which have parallel utilization in semiconductor industry. And of course, as I told, as you may be aware, that Government of India has a huge push of quantum mission, under which also associates itself with the semiconductor technology drive. And of course, we have certain degree of interest. It must grow much bigger. Industry also has to come because if you look, IBM has a very strong interaction of it has its own research lab and other things. We have our industries which are slowly coming into semiconductor space, and that's where little connections are there, but it has to grow. It's a very futuristic thing. So, now if you think in terms of quantum material, so across world there's huge interest. So it's not because this is where the world would be. This in terms of materials, new materials, because every progression happens when you find a new material. So topological materials are new materials. So there is a huge interest across the world, of course, US, Japan, China, South Korea, and there are many other countries who are there. India is also starting. We have initiated various. There are few programs. As I said, in my own project, we are going to develop new materials, but we are in the early stages. Of course. But we have scientists who are very well qualified and have knowledge from their past research experiences, and so we are in the competition. And but yeah, we are in the beginning stages at this point. I have papers. I have about 30 papers, and these are primarily on quantum material and growth kind of thing. This is very useful because, as I said, this is where you will have low energy materials, which means you will consume less energy, faster devices, because every next generation requires faster, low energy. These are the two and low small space consumption. Right? So all these three are the basic pillar of the research that we are doing. So it will affect in terms of energy saving. It will of course faster manipulations and computation, and of course smaller and lighter. So it's of great use for common man in general and for progress of science in India. Actually, if you see across, we have started for sure now. See, this field itself came into its major recognition around the manifestations were there before around 2005. There was a very seminal work by scientists which led to a realization that we can have new such material, but this field has exploded since 2005 only. Now world has recognized that if you want to go for next leg of revolution, if you want to say, even in terms of device revolution, industrial revolution is always led by device revolution and new technologies. This is the basic input where we have to work on. So this is very important for Indian science and logical material, quantum materials. This is where this will lead to new technologies, because if you it's there are two ways to growth. One growth is optimization of existing technology, or otherwise you have a path breaking technology. If you talk about a path breaking technology that creates industrial revolution kind of thing, then you need to have a novel material design and all other thing, and this is what it will take India to, and that's why it's very important. Yeah, so I think I talked about my research only in a way all through. So essentially, as I said, we are working on the word is quantum material, and it's as I said, a quantum material is something in which the properties are driven by quantum effects, which happens only at a very small length scales. When there is collection of electrons coming together at a very small length scale, you get new phenomena happening, and we are looking for that. Especially we are working on spintronics application, which means spin based applications. And the message that I want to carry forward is that there is a huge need to understand that for any application it is very important to understand the science behind it, and we need even younger generation to come up and get excited about doing research in fundamental sciences. Needs to be now, because we talk so much of application industry, we lose the sight that behind every technology that has come up, which might have come up 50 years, 60 years later after the initial discovery of a major breakthrough in fundamental science, that has to be understood. And for that it needs, of course, time, patience and hard work. And for that, younger generation also has to come up, do research and get more excited about it.
STEM बात पते की।
क्या आप जानते हैं पुरुषों की दाढ़ी आती है, औरतों को क्यों नहीं? जन्म के बाद मानव में सबसे ज्यादा विकास किशोर अवस्था में होता है। 11 से 13 वर्ष की उम्र में किशोरों में यौन ग्रंथियों का विशेष विकास होता है। इस उम्र में पुरुषों के यौन ग्रंथियां एंड्रोजन हार्मोन पैदा करती हैं, जो दाढ़ी और छाती के बालों में वृद्धि करते हैं, जबकि स्त्रियों की यौन ग्रंथियां एंड्रोजन की बजाय एस्ट्रोजन हार्मोन पैदा करती हैं। इसी वजह से पुरुषों में दाढ़ी होती है और स्त्रियों में नहीं।
ये था आज का विज्ञान की आवाज। आपको ये पॉडकास्ट कैसा लगा हमें बताएं mediaforcommunity@gmail.com पर।
आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Salam Namaste Community Radio, Noida.
एक नई दुनिया की आवाज